All right. So longitudinal dynamic stability, we have three different possibilities. What are the three different possibilities? Check. Number one, we have no overshoot. Okay, that is also called heavily damped or deadbeat. Then another is oscillation, oscillation, oscillations die away, and third one is the oscillation divergent. Oscillation divergent. Okay, just try to connect with this. No overshoot means we are having a heavily damped condition. What is the damped condition? I will tell you. Damped, or which is also called deadbeat. What it is called? Deadbeat. In different book, different name they have given. So I considered all, and so just write this. And oscillation die away called slightly damped. It is called slightly damped, and oscillation divergent is called undamped. Undamped. This is 1, this is 2, and this is what, 3. What is the mean of this? See, simply, if it is heavily damped, so that heavily damped means very fast it is going to reduce the amplitude, called a deadbeat, or it is the called heavily damped. Means because of the disturbance, that airplane will get oscillation, and that oscillation, if it is going die out with very fast speed, it means it is heavily damped. So how that graph will be there? So that graph will be something like this. It is called a heavily damped. It is called heavily damped. It is called heavily damped. It is also called deadbeat damping. What it is called? Deadbeat damping. Okay, number one. This is the number one. What is the number two? Number two is nothing but oscillation die away. Oscillation die away. Obviously, we have oscillation. In case of the dynamic stability, we have to talk about the oscillation. So this oscillation is what die away, and it is slightly damped. Slightly damped means it's very simple. By word only you can understand. Damping is there. Damping meaning is itself is what? Reduction of the or decrement of the amplitude. If it is heavily damped, it means amplitude is what? Immediately it is going to reduce. Okay. So heavily damped means actually it will not even able to oscillate simply from here. See, from some amplitude to initial means till initial condition it will go. It will not continue their oscillation. That is called no overshoot or heavily damped. But if it is oscillation is there and it is slightly damped, so oscillation means it will have oscillation. Oscillation means both positive and negative. So that oscillation will be like this. This is what oscillation. This is what oscillation. But this is slightly damped. It means immediately it will achieve its initial condition. That is called slightly damped. And this is also called as a convergent. This is also called as a, just like this is called deadbeat. So this will be called as a convergent. Why it is called convergent? Why it is called convergent or damped oscillation? It is called convergent or damped oscillation. Why it is called convergent? Because now amplitude is what? Going to reduce. Hence it is called convergence. So this is the second one. And what is the third one? If you go for the third one, what is the option? Oscillation will be there, but it is divergent. Oscillation is there, but it will be divergent. Divergent means that it is not going to converge, it is going to diverge. Now diverge means that amplitude is what? Continuously it is going to increase, like see. So it will be what called undamped. Damped means what? That amplitude is what going to reduce, but undamped means it is not going to reduce, right? And still it is not going to reduce. That is one thing, but it is divergent. It means that amplitude is what continuously going to increase. Hence, it is called divergent. So these three chances, or basically we have three possibilities, okay, for the longitudinal dynamic stability, as I have shown you. Okay, now both longitudinal dynamic stability modes are excited whenever the airplane is what disturbed from its equilibrium or trim condition. Okay, how that disturbance will come into picture, I told you there are two way to get disturbance. Maybe it's because of the pilot control input. Pilot control input means, as I told you, maybe his pilot is what going to change the power setting, or maybe he's going to change the, he's going to use control surfaces like flap deployment and all. Okay, so that is because of that, that it will get disturbed. Okay, means that atmospheric influences will comes because of the that control inputs, because of the pilot control inputs, basically. That is one. Second is what? Because of the gust, because of the air, because of the turbulence. So two reasons are there. Okay, and that may, any of the reason will have all three possibilities in case of the longitudinal dynamic stability. This is the one thing. All right, now it's clear to you, like whatever the oscillation you may have here, now it is, you are now very clear. We have oscillation in case of the longitudinal dynamic stability. So two possibilities are there for the oscillation. Like maybe that oscillation will be a short period, or maybe it is long period. Short period pitching or long period pitching, just try to understand my point, because we are talking about the longitudinal stability. So we'll talk about the pitching moment. Pitching means nose up and nose down. So two possibilities are there: short period and long period. Okay, if it is related to the short period, then what will happen? And if it is related to the long period, then what will happen? That we have to discuss here. Okay, one by one. So first I will give put here short period oscillation. Okay, number one, short period oscillation. Number one is short period oscillation. Okay, short period oscillation. Here I have not written the basic definition of the time period, frequency and all. You have to know that. Okay, so that concept I have to use, you will understand, don't worry. If I say short period oscillation, then what is the mean of it? Simple. Short period and long period, two options are there. So first is the short period. Short period means that time period to complete one cycle is short, means very small. It means very high frequency, because frequency is what just opposite, or inversely proportional. Frequency is just inversely proportional to time period, right? So if it is the short period, okay, if it is the short period oscillation, it means that frequency is very high, right? So if frequency is very high, so when this short period oscillation will come into picture, there is the reason. When it comes, you just need to write somewhere, so you will remember. The short period oscillation, short period short period oscillation, okay, or short period mode, both are correct, is excited by change in angle of attack. Change in angle of attack. Try to understand this. What is the mean of it? When the pilot will change the angle of attack, okay, or it that change in angle of attack may be because of the pilot inputs, or maybe it is because of the gust, sudden gust. Okay, so both options are there. As I told you, two types of disturbance. One is what pilot control inputs, like flap deployment or any control surface changes or power setting is what changing by the pilot. Then disturbance will be there for the airplane, and another is what the air gust. Okay, or sudden gust will come and hit to the aircraft. So the two options are there. So because of that disturbance, if angle of attack is what change, then this short period oscillation will come into picture. Okay, right. And obviously once it occurs, then this type of uh, the short period oscillation will be basically the aircraft abruptly return to stick to neutral when the aircraft is what trim attitude, and observe the damping of short period oscillation, and it subsided very quickly, means that aircraft uh, that oscillation is basically short, but meaning that frequency is what that period is what short period oscillation, but frequency will be very high. If you see the frequency is what very high, so how it will be like, see, it will be like, I'll draw one diagram so it will be more clear from here. Suppose this is now the short period oscillation. So how it starts, see, it will have like this is the short period oscillation. This is the short period oscillation. So basically, the short period mode is typically a damped oscillation. Okay, it is a damped oscillation. Why? What is the mean of damped oscillation? Means the amplitude will continuously decreasing, and it will achieve the trim condition or equilibrium condition. Okay, so always remember your short period oscillation. These are 1 marks question. Okay, you always remember. So this short period oscillation, always remember short period oscillation. Short period oscillation is typically remember they are asking for 1 marks. Okay, typically damped oscillation. I already have explained you what is the mean of damped oscillation. Damped oscillation. Okay, always remember they can ask to you in examination. Short period oscillation is damped oscillation, undamped oscillation, convergence oscillation, divergent oscillation. Like that question will be asked to you. So you have to answer for this. Okay. It is the damped oscillation, means amplitude continuously it will be decreasing, and it will decrease very fast. Okay, very fast, because it's a short period. So if time period is very less, then frequency will be very high. That's the mean of it. Okay. Number one. Number two, for the short period oscillation, what you have to remember, what is changing here, the angle of attack is what continuously changing, up, pitch down. I mean, angle of attack will increase, decrease, increase, decrease, increase, decrease, and ultimately it will, at last it will be settled down. Okay. So always remember the angle of attack will be changing continuously in short period oscillation. Okay, that is one very important point you need to make a note, or you just remember. Okay, that angle of attack will be changing. Number this point you need to remember. Okay, note angle of attack. Angle of attack. This is also for 1 marks. You need to remember. Okay, angle of attack. Angle of attack continuously changing in case of the short pitch oscillation. Okay, angle of attack is what? Angle of attack is changing in 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 short period oscillation. Short period oscillation. Okay, this is one very important point you need to remember. Now, so You can think, if short pitch oscillation is there, then it is more uh, 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 dangerous thing I can see. Why? Because if it got disturbance, then it will try to come back very fast, and for that reason, that pitch up pitch down will be very fast. So it may give jerk. Suppose it is passenger plane, then it may give jerk, and it will be a feasible. I mean, you will able to feel that, okay, there is the uh, oscillation started because of the disturbance. Okay, that is one. And why it is dangerous? Because I told you that it will hit, uh, it will give the feel like, okay, pitch up and pitch down or disturbance is what there, because that time period is what very small, and frequency will be very high, so very fast it will have a pitch up and pitch down. Okay, that is one. Now coming to the next, which is called long period oscillation. Okay, which is called long period oscillation, and this is very important. Second one, we have long period oscillation. As I told you, this is related to longitudinal dynamic stability. Okay, so this is now long period oscillation. Now again you can see what is the frequency, inversely proportional to time period. Okay, so as you can see here, time period is long, means high, then frequency is very small. So whatever changes you may see in the attitude of the airplane, it will have very low frequency, so that passenger even may not able to feel that. Okay, because time period is what very high. I mean, one cycle will complete in, suppose, 10 minutes, 20 minutes, like that, just for example I'm saying. So that it may not give any kind of jerk. First thing, even the passenger or who were there not able to feel that actually. Okay, that oscillation, because frequency is very less, time period is very high. It's like, see, it's like this. See, two types of oscillation I can show you. This is the oscillation here, like this, and one oscillation is like this, like this. So this, if you talk, then this is the long period oscillation. Okay, this is the long, or and this is the short period oscillation. This is the short period oscillation. How you will measure the time period? You know very well, from peak to peak, any point, peak to peak, this time taken is nothing but time period. Peak to peak, okay, from here to here you can take, this is the time period. So this is what long period, this is what short period. In this way you can understand. So in case of the long period, frequency will be very less. This type of motion also called as long period note. This one you need to remember, in examination they are asking. Okay, they are asking, so please make a note. This long period oscillation, this long period oscillation also called as phugoid. This is very important. You write, ma'am, phugoid they had asked in exam. This is called phugoid motion. What it is called? Phugoid. Phugoid. Phugoid motion. Okay. This is called phugoid motion. Long period oscillation, also called as phugoid motion. For 1 marks, you need to remember. Number one. Number two, that about phugoid motion, few important things you need to write. So better I will give the heading and will write 2 points. Phugoid. Okay. So for the phugoid motion, we have to write number 1 point. Um, we have to say, for the phugoid motion, first one, it is the long period oscillation. It is long period oscillation. Number one, long period oscillation. What is number two? Number two is, it is constant angle of attack motion. Okay, constant angle of attack. Phugoid motion, better I will write. So for phagoid motion, 2 points you got. Long period, it is called long period oscillation, or in phagoid motion, we have a long period oscillation. In phagoid motion, we have a constant angle of attack. Constant angle of attack. Okay. And very important, that variation. In case of phagoid motion, two things are constant: long period oscillation and constant angle of attack. These are the constant thing, but two things are the variable. Okay, two things are the variable. What is the variable thing? That is speed and altitude. So these two are one. And third point you need to write, third point you need to write, in phagoid motion, aircraft is and altitude. Okay, uh, aircraft speed, I must write aircraft is and and altitude, and altitude. Okay, altitude, altitude changes during motion. What motion? Phagoid motion. So during phagoid motion, aircraft speed and altitude both are changing. Okay, or it changes during motion. So these 3 points are very very important. In short, I will write here. In short, I will write here. In short, I will write here. Number one, angle of attack alpha is constant. Number two, okay, number two, that aircraft speed changes. Number three, altitude. These 3 points very very important points for the exam point of view. So you please remember this. Okay. Now, so you can think there. Here I.
Sir,
Yes, yes. Please ask any question you have immediately. You can ask. No problem. Ask question.